Hello everyone, myself Ankur Patel, and today in this second session of development of surfaces we are going to discuss examples of the solid objects which are developed radially. So before going on to the example, let us see the objects in which the radial development are possible. So cone. So the development of the cone is a sector of a circle which have a radius equal to the length of the generator of the cone, and the sector will be up to angle theta, or the angle of the sector will be theta, which will be equal to capital R upon L into 360 degree, where R represents the radius of the base circle and L will be the length of the generator. Now let us see the development of this pyramid. So here we have taken the square pyramid, and in case of the cone and pyramid the development will be radial. So the development of the square pyramid will be a number of triangles attached at the same point. So right now we have 4 triangles which have a length or side length equal to L and base length equal to S, where S is the base edge length of the square pyramid. So the development will be 4 triangles attached at the same point, and this development is known as the radial development. So if we have pentagonal pyramid, we will get 5 triangles. If we have hexagonal pyramid, we will get in the development 6 triangles. Now let us see the example of the solid object in which radial development are possible. A right angular pentagonal pyramid, 30 into 60, that means 30 is its base edge length and 60 is the axis height, is resting on its base with one of the side of the base perpendicular to VP. Draw its projection. An AIP inclined to HP at 60 degree and perpendicular to the VP cuts the axis at the distance of 30 mm from the apex. Develop the lateral surface of the truncated cut pyramid. Now here the object or the solid is the pentagonal pyramid, which has its base on the horizontal plane by one of the bases perpendicular to VP. So first of all we have to draw the front view and top view of the pentagonal pyramid. So first of all draw the XY reference line. Here we will also draw the projection by using the first angle projection method. So we will get the top view below the XY reference line and front view above the XY reference line. And right now the base of the pentagonal pyramid is on HP. So the top view of the pentagonal pyramid will be the true shape of its base. So we'll start with the top view, and it will be a pentagon. So draw a pentagon by taking one of the side perpendicular to the XY reference line, because here we have to show one of the side of the base perpendicular to VP. So if we will take side perpendicular to XY reference line, it will be perpendicular to VP, because if we are drawing the top view, XY line will be our vertical plane. So draw a pentagon like this by taking one of the side perpendicular to the XY reference line having side line 30 mm. Mark the points A, B, C, D, E. Now we have to show the slant edge also in the top view. For that we have to find out the center point, and to find out the center point we have to connect the midpoint of one of the edge to the opposite corner. So draw that edge from the midpoint of this edge and connect it to the opposite corner. Find the midpoint of this edge and connect it to the opposite corner and mark this point. So this point will be our apex point, that will be our O. Now connect O to all the corner of the base, which shows the top view of the slant edge. Now we have to draw the front view, and right now the front view of the pentagonal pyramid will be a triangle. So for that we have to project all these points vertically upwards. Project all these points vertically upwards. So this will be A dash, B dash, C dash, D dash and E dash. Connect this. This will be the front view of the base. Now take the projection of the apex point. Measure the axis height, which is 60 mm. Here we will get O dash, will be with the front view of the apex point. Connect the apex point to the base corners, that is O dash to A dash, O dash to B dash E dash, and O dash to C dash D dash, will give us the front view of the pentagonal pyramid. Now first of all we have to show the basic development of the surfaces before taking the section. So right now in the elevation, the slant edge O dash A dash will give us the true length. And how can we define that O dash A dash will gives us the true length? Because you can see the plan of the slant edge, that is OA, is parallel to the XY reference line. And if the plan is parallel to the XY reference line, in the elevation, the length of the slant edge will gives us the true length. So right now the slant edge O dash A dash will gives us the true length. So first of all, draw a line having length equal to O dash A dash and parallel to O dash A dash over here. This will be our O and this will be our A. Now taking center at O and radius is equal to O to A, draw an arc, and on this arc now give another arc measuring from A and radius is equal to the length of the base edge. So measure 30 mm, put your ruler over here, give 5 arcs on this arc. So 1, 2, 3, 4, 5. So this is A, so this will be our B, C, D, E, A. Connect AB, BC, CD, DE and EA. Now connect all these points to point O. So OB, OC, OD, OE, OE will be the development of the or basic development of the pentagonal pyramid. It will gives us 5 triangular faces having base length equal to the length of the base edge of the pentagonal pyramid, and this side length will be equal to the length of the slant edge O dash A dash. Now we have to take the section. For that we will show the cutting plane in the elevation, because right now the cutting plane is AIP, auxiliary inclined plane. So we have to show this cutting plane which is inclined at an angle of 60 degree to the HP and perpendicular to VP, and cut the axis at a distance of 30 mm from the apex. So first of all measure 30 mm from the apex, draw a line. So our cutting plane will pass from this point, the intersection point of this line and the axis. So now from this point draw a cutting plane line inclined at an angle of 60 degree to the XY reference line. So draw a cutting plane line or show a cutting plane. Now mark the intersection point of the cutting plane to the pyramid. So mark this point and this point. So this point will show the intersection point of the cutting plane with the slant edge OC and OD. This point will show the intersection point of the cutting plane with the slant edge OE and OB, and this point of the cutting plane will gives us the intersection point or will shows us the intersection point of the cutting plane with the base edge AB and AE. So AB and AE, it will cut to the base edge AB and AE. Now after showing the cutting plane or the intersection point of the cutting plane, we have to remove the upper part of the pentagonal pyramid. So the part below the cutting plane is shown by the visible outlines. So draw the visible outlines in the part below the cutting plane. Now we have to extend this point in the development of the pyramid. So for that, first of all extend this point on this line over here. Now take center at O, radius and measure the radius of this distance from O and give an arc like this. We will get the intersection, or we have to take the intersection of this arc on OC and OD slant edge. So mark the intersection point of this arc on OC and OD slant edge. So mark this point. Now project this point on this slant edge OA and measure this distance from O and take center at O and give an arc, and mark the intersection point of this arc on this slant edge OB and OE. So on this slant edge OB and OE, mark the intersection point. So this will be the intersection point. Now we have to find this intersection point. We doesn't get the intersection point directly like this. So for that, first of all we have to project this point in the plan. So project this point in the plan and mark this point. Now measure this point A to this point, give an arc from this point A on the base edge over here, measure A to this point and give an arc taking your rounded over here on the base edge AE. So mark this point. Okay, now give the name of this point P Q R S T U. So we will get RS over here, P U over here. So mark this point as P dash U dash, this point as Q dash T dash, this point as R dash S dash, and mark these points. This will be our P and this will be our U. Now connect these points PQ, QR, RS, ST and TU. Connect this point P to B, BC, CD, DE and EU, and mark the, also join this point QB, RC, SD and TE. So this will be our final development after taking the section of the pentagonal pyramid. So this is it for today. Thank you for watching. See you in the next lecture. Till then, take care.